Chapter 4, Chemical Quantities and Aqueous Reactions. The greenhouse effect. Okay, so this is one of the topics in the book, which I think is very useful because it shows how chemistry applies to the world we live in and things that are important in politics and stuff. I'm not going to test you on the greenhouse effect, okay? So the greenhouse effect is that our atmosphere acts like a greenhouse and keeps our planet warm. So energy from the sun comes through the atmosphere, warms the surface, and then some of the heat that it gets radiated off gets trapped by the greenhouse gases. So the greenhouse effect is critical for our survival. But we have to have a balance, right? If we've got too much greenhouse effect, then the planet's going to get too warm. Not enough, and it's going to be too cold. So one of the greenhouse gases is carbon dioxide, and we've been measuring carbon dioxide for a long time now, and we have observed that there's an increase in atmospheric carbon dioxide concentrations. So from 290 parts per million up to about 400 parts per million. That's a big increase, 38%. We also see that average global temperatures have risen during that time as well. Now this graph looks very dramatic, doesn't it? But look at the range of the temperature here. So if we start here, for a while the temperature went down, and then it started to go up, and it's not a smooth curve like this. Well, that's not smooth, but you get, this is a lot more jagged. Ups and downs, but overall there is a trend of increasing temperature of 0.6, 0.7 degrees Celsius. So depending on who you talk to, that's extremely disturbing or just something to keep an eye on. What we're interested in is this increase in carbon dioxide causing the increase in temperature, or is it just a coincidence? So are the two trends causal? Is one causing the other, or are they just coincidental, happening at the same time? Depending on who you talk to, that's open to debate. So one source of CO2 is combustion reactions of fossil fuels. So most of us probably came into school in a gas-powered vehicle, right? So you burn fossil fuels and carbon dioxide goes into the air. Now carbon dioxide is not hazardous any more so than nitrogen gas in the air, but the concentration of it in the atmosphere does lead to warming of the planet. So this is a representation of the chemical reaction occurring when we burn fossil fuels. Here, C8H18, what do you think that might be called? What's the base name for 8? Oct. So this is octane. There's octane in gasoline, right? High octane is better for the performance or whatever. So this is not all that's in fossil fuels, but there are like a gazillion different compounds, and so we're just going to use this as representative. When this reacts with oxygen, it forms carbon dioxide and water. So that's a source of CO2. Another source of CO2 is volcanoes. Volcanoes are spewing carbon dioxide into the atmosphere. So how could we figure out whether the global warming is like just from volcanic action or is it from our use of fossil fuels? Well, we could look at this chemical reaction and estimate based on our knowledge of how much fossil fuel was burned. We could estimate how much carbon dioxide is being emitted from the combustion of fossil fuels. Doing it from volcanoes is a little trickier, but people have measured that. They are estimates.